Okay, let's begin. Question 2 from exam 1. Let f of x equal this piecewise function. Graph it, and then we'll figure out whether it's continuous at pi over 2. Okay, so we got x squared when x is less than 0. And I didn't put y values here just because x squared and sine x, they're not going to, their y values are going to be a little weird. Because sine, we wanted the x values to be in terms of pi, but negative pi over 4 squared is weird, so we'll ignore that. Now when x is less than 0, we get x squared, so that's going to look something like this. Now because I don't include 0, I'm going to put an open dot there for now. And x squared on this side is going to look something like this. Okay? Alright, ignore the y values over here. We know that x squared has to look like this. Now sine x from 0 to pi over 2. Now when when x is pi over 2, sine is 1. It's going to look something like this. And I don't include pi over 2, which means I have an open dot there. But I do include 0, and sine of 0 is 0. So even though that it was open because of the x squared, it's now closed because of the sine. And then x minus pi over 2. Okay, when x is greater than or equal to pi over 2. Well, this is a straight line, a slope of 1. And when x is pi over 2, you get 0. So it's going to be starting off here. Notice I get to include pi over 2, so I do have a closed dot. And it'll look something like this. Okay, is f continuous at pi over 2? Well, no. You can tell right here, we have a jump. The reason why, and then explain your answer using limit notation, our answer will be no, because the limit as x approaches pi over 2 from the left does not equal the limit as x approaches pi over 2 from the right. Because there are three conditions to be continuous. There had to be a limit, and there's not. If the limit exists, which is, we need that, it also has to equal the y value at that spot. And there has to be a y value at that spot. So it didn't satisfy the first condition where a limit must exist. So, answer no.